You're listening to a podcast from 702 and Cape Talk.
702 and Cape Talk.
The Naked Scientist.
It is 9:34 on 702 and Cape Talk. It is time for The Naked Scientist. Chris Smith, of course, is back with us this week, and we've just opened up our lines, taking your science questions on any subject. Chris, good morning to you. I hope you're well. You're in Australia, you are?
Yep, I'm down in the bottom southwest of Western Australia. And this is actually one part of the world where the tallest trees in the world grow. Just not far from where I'm sitting are the three aces, which are three huge eucalypts, which are nearly 100 meters tall. Amazing.
All right, beautiful. Just to kick off with our science story of the week, I remember reading this a couple of days ago, and I was wondering if we will have an opportunity for you to unpack it. DNA could be used to store digital information and preserve essential knowledge for thousands of years. What's the story?
Well, researchers and technologists are always looking for safe and secure ways to store information. We're comfortable with the idea that you could chip things into stone and you can dig up or read old books in libraries, which are maybe a couple of thousand years old. But can we make information last even longer and be even more resilient to the test of time? And researchers are now beginning to look at DNA as one way to write information and lay it down for long-term storage, almost like a computer hard drive, but a hard drive that uses DNA. And this is based on the premise that we can go to fossils and we can get DNA out of fossils that's thousands, if not tens of thousands, and in some cases, possibly in Spain, there are fossils coming out of Spain that are hundreds of thousands of years old, and they're yielding intact DNA. For instance, we know the genetic code of extinct Neanderthals, which were another lineage of early modern humans. So we know that DNA appears to be very robust and resilient and capable of withstanding a very harsh environment and remaining readable. What researchers are therefore doing is testing whether DNA could replace a computer hard disk. It sounds a little bit futuristic, and indeed it is. But what they're actually doing here, and this is Robert Grass, who's a researcher at the Swiss Federal Institute of Technology, they are taking computer data, they're taking published books, they're even taking data, a book written by Archimedes, and you convert the language of the book into unique DNA code, because DNA's got 4 letters in its alphabet. So in the same way that the DNA alphabet writes the recipe for a human being, you convert the written word into a sequence of DNA letters. They put that DNA sequence inside tiny particles of silica, glass, which they then baked at 71 degrees C for a long period of time. And this simulated as though they'd been in the ground for thousands of years. They were then able to crack open the little beads of silica, get the DNA back out and read it in the same way that scientists are reading DNA sequences in laboratories all over the world. And the DNA code was intact, and they got back the documents that they had put into DNA format. So they're suggesting that, for instance, 1 ounce of DNA could store 300,000 terabytes of data, which is a lot.
It sounds very much like a tool that can be used in espionage as well, Dr. Smith, just thinking about it. But this is most fascinating. And how far are they in terms of making this a reality? Are we still in the test phase, or is this a done deal?
Well, the problem is that it's very expensive. Reading DNA sequences at the moment, despite costing a fraction of what it did a decade ago when the Human Genome Project was being completed, it's still relatively very expensive. When you think that you can go to the computer hardware shop and you can buy yourself a 2 or even a 4 terabyte hard disk, and it's not going to cost you very much money, compared with that, this is extremely expensive. But it's an early technology, and it just goes to show that it's possible. It's a proof of principle. No one's going to build you a computer storage device based on DNA tomorrow, but you've got to start somewhere. And I remember the first hard disk I ever owned. It was 10 megabytes, and it cost me a month's salary. And,
right.
Nowadays we're talking terabytes, not megabytes. Of course, we all have to start somewhere. And so this is really, I think, a glimpse into what is the future.
Yep, we take your calls on 011 883 0702 and 021 446 0567. The Naked Scientist is here. What are your questions? You can also ask via SMS 31702 and 31567. Let's start off in Randburg. Joy, good morning.
Good morning. Chris, something I'm very curious about. My blood group is A negative. My husband's blood group is A positive. Would my children have to have either one of those blood groups, or could it be something totally different?
Right. Well, the way in which blood groups are determined is as follows. Your red blood cells have markers on the surfaces, and these are sugar molecules, which are what we use to define the blood group you are. If you have A-type sugar molecules, then you're group A. If you have B-type sugar molecules, you're group B. If you have group A and group B sugar-type molecules, you're group AB. If you have none of those molecules, you're said to be group O, O for naught or nothing. The genes that give you those blood groups are either A genes or B genes or neither A nor B, the group O. When you have a baby, the parents have one copy of each of those genes from their dad and one from their mum, and that means that you give either your group A or your group B gene to your offspring, one copy of it. Now, a person can be group A if they have one A gene and one O gene, or they have two A genes. They can be group B if they have one B gene, two B genes, or they're group O if they have neither an A gene nor a B gene. A baby, therefore, will inherit one of those possibilities from each parent. So if you have a group A mother, that means the mother could be giving an A or an O, assuming she's got an A and an O gene. A dad who's group O will only give O genes. Therefore, the baby could be group O or could be group A in that setting.
All right. Joy in Randburg, thank you very much for that. Zuki in Cape Town, thanks for your patience. Good morning.
Good morning, Gogetson. Morning, Chris. I've recently heard that if you keep an onion in your bedroom, it absorbs germs and therefore you don't get sick. Now, to me, that sounds like a bit of an old wives' tale. Is it true? Is it possible?
I'm not aware of any evidence that keeping an onion in your fridge or keeping an onion anywhere will ward off germs or soak up bad things. It will make your fridge smell bad eventually, and if you eat lots of the onion, it might make your breath smell bad, but it probably won't make much of a difference to the germs. The reason the onion actually makes the chemicals that give it that very pungent smell and makes you cry when you cut into it is because it contains a lot of sulfur-containing chemicals. And this family, this allium family of vegetables, make these chemicals to ward off animals from eating them. It's like a chemical defense. They're very pungent, they're very strongly flavored, and they deter animals from eating the flesh and therefore harming the plant. We just happen to quite like those chemicals because they give food a nice flavor, so we actually eat them. But they're not necessarily poisonous. They're just not very nice to eat, which is why the plant makes them, in order to put things off from eating them.
Okay, thank you.
All right. You also don't want your room smelling like onion, Chris.
Well, exactly. You don't want your fridge or your room smelling like onion, do you?
All right. More to the calls. Anne in Centurion, your answer, rather question for Chris.
Yes. Good morning, Chris. I'd like to determine what is the difference between cold hands and warm hands. In the winter, my hands are ice cold, right? As soon as the temperature drops. And yet in the summer, as I say, I'm in my late 70s, in the summer, my hands are beautiful and warm. I'm in the sun, I'm in the pool, I'm doing everything. But in that winter, I cannot understand. My husband says, oh, it's your circulation system. I said, listen, I'm not going to listen to anybody unless I find out the truth. Why is it that as the temperature drops, my hands go cold?
Your body contains a lot of blood. You've got about 5 litres of blood circulating around your body. And your body temperature is controlled by manipulating how much blood flows close to the surface of your skin, because your skin allows cold air to carry away heat from inside your body. The more blood that flows close to the surface of your skin, the more heat you'll lose. On a hot day, where your metabolism is churning out heat, and it's hot in the environment or hot in the room, the rate at which you're losing heat into the environment is quite low. So the body increases the ability of the body to shed heat by increasing the blood flow through your skin, and particularly through your peripheries, which includes your hands and your feet. Your fingers have a very big surface area, so diverting a lot of blood into your fingers radiates and conducts a lot of heat out of the body. As soon as the temperature falls, though, the rate at which your body is losing heat increases, because the gradient, the difference in temperature between you and the environment, is now much greater. And to conserve heat so you don't get too cold, the body shunts heat away from the periphery, away from your hands, away from your feet, and keeps it in the core of your body to keep you warm. And therefore, if you restrict the amount of blood that's hot flowing into your peripheries, like your fingers, they will get colder because there's less warm blood flowing in, and they're exposed to the cold air, so they've lost some heat to the environment. And so that's why your hands are colder in winter, because your body is keeping the blood in the core to keep you warm.
All right. And in Centurion, I hope you're happy there. In Santon, Keith, your question for the Naked Scientist.
Good morning. My question is, can you slow down or prevent oxidation in vegetable oil?
You got that,
right.
Chris?
Well, what do we mean by oxidation and vegetable oil? When we're talking about cooking oils and things, we're talking about chains of carbon atoms, which are all linked together to make hydrocarbons. And carbon can link to other carbon atoms by making what we call a single bond, which is where one pair of electrons are shared between the carbon atoms, or a double bond, where two pairs of electrons are shared, or in some cases, triple bonds, where there are three pairs of electrons involved. Acetylene is an example of that. You don't normally cook with acetylene, though. So many of the oils that we cook with, if they're from plants, will carry these so-called double bonds, and they're unsaturated, they're polyunsaturated, or if you cook with olive oil, they're monounsaturated. But these double bonds are more reactive than single bonds, and this means that when you raise the temperature and you cook with the oil, then side reactions or chemical reactions can happen that lead to those double bonds breaking apart and forming new bonds to other things. And sometimes they can make things that are poisonous, or they're not so good for you. And when oil is used and reused many times and heated and cooled to high temperatures, cooled down again, it encourages that to happen. And because we regard these oils that have been oxidized in this way to be less good for your health, you're advised to change your oils regularly that you cook with. There's not really any way to stop that process happening because it's a natural chemical reaction. The best thing to do is just to not raise the temperature of the oil too high, because the higher the temperature, the more likely these bonds are to be rearranged, and also not to keep reusing cooking oil for extended periods of time, because eventually it will become saturated and oxidized, and we regard that as less good for your health.
All right. Keith in Santon there. It is 9:48. The Reedy Tlabi show, Koketso Sachane, standing in for Reedy. Of course, the lines continue to be open. We're speaking to the Naked Scientist, Dr. Chris Smith. We're also taking your SMSs on 31702 and 31567. You can also ask your questions via Twitter at Radio 702, at Cape Talk 567, at Koketso Sachane. Let's just take Alex in Joburg. Good morning.
Hello, Chris. Can you hear me?
Hello? Clear.
Okay. I just want to ask something about evolution. The consensus is that we evolved from microbes and in the sea and so forth. And the scientists have dug up skeletons of some of our ancestors, like Neanderthal man and those kind of people. Where are
okay. I'm not too sure. We've got a bad line there with Alex. Hopefully we can get him on a better line. Let's go to Jeff in Four Ways. Jeff, good morning. Good morning, Jeff.
Is that Chris?
Yeah. Oh, okay. Lost him as well. Nash in Rudaport. Have you got a question for the Naked Scientist?
Yeah. Morning. How are you?
All right.
Good. Look, I work out quite a bit, right? But I've realized there's certain exercise that when I do, I end up with a headache, in particular the ab exercise. Now, I was wondering what would cause that? What would be the reason for that?
All right. Line was not very clear there, Chris, but what are those? Why is it that certain types of exercises cause headaches?
Some people do say that when they exercise and they take intense exercise, they do develop headaches afterwards. There's a number of reasons why that might happen. Very commonly, when people exercise, then they lose a lot of water because they become hot and they sweat. And when you sweat, you lose both salt and water, and you also blow out a lot of CO2 if you hyperventilate. And all of these things can perturb your blood chemistry a little bit. And this can actually, because you become a bit dehydrated, can lead to a headache. One of the signs of not drinking enough water is getting a headache. Also, if you don't eat properly, and you take vigorous exercise and you haven't got enough energy or food on board to supply the energy demands of the exercise, this can also cause you to have a headache. So if you are getting a regular headache when you exercise and you're otherwise fit and well, then it could be one of those factors or a combination of those things. On the other hand, if this is a new symptom that's only just begun to happen, when you exercise does increase your blood pressure. And certainly the systolic blood pressure becomes very high when you're exercising, and that's normal. But if you have a vascular problem, then actually it might be a risk. So it would be worth, if this is a new symptom and it's happening reproducibly and something might be wrong, it could be worth getting that checked out.
All right. Alex in Joburg, I hope we've got you on a better line. Your question, please.
Yeah, is it a better line now?
It definitely is. Go ahead.
Okay, I just want to know if the consensus is that we evolved from the sea or from bacteria, whatever microbes in the ocean. They found skeletons of Neanderthal man and a few others. Where are the skeletons of each stages of evolution? They never seem to found anything like that.
If we wind the clock back on Earth, you find that life here got started really quite early. By about 3.5 billion years ago, we've got evidence of the activities of early life on Earth. But that early life was pretty primitive. It was single-celled organisms. You can still find evidence of them. In fact, here in Western Australia, along the coast from where I am, there are structures called stromatolites. You can also find very big stromatolites fossilized in South Africa. These are rock structures built by generations of microorganisms. Now, they were on Earth modifying the environment and flourishing, actually, for billions of years. And it was only much more recently, within about the last 600 million years, so in other words, really in the blink of an eye in the age of the Earth, which is 4.57 or so billion years old, it's only much more recently that more complicated life came along. And about 2 weeks ago, researchers at Cambridge University, this is a lady called Emily Mitchell, if you want to look up the paper, it was published in the journal Nature, she has described an intriguing form of early life, which dates from a period known as the Ediacaran, which is 565 million years ago. And she has described this interesting organism called Fractifusus. And this lived on the seafloor, and it resembled a cross between a slug and a squashed fern leaf. This organism had no mouth, and it just absorbed all its nutrients from the water. And it lived on the seafloor, and it reproduced by splitting bits of it off and spitting those particles into the water, which floated off down tide and started a new colony. But it also cloned itself by putting out runners like a spider or a strawberry plant. So the early life evolved from those sorts of creatures and became progressively more specialized, ultimately culminating in organisms like fish. And we know fish and sharks were around by 200 or 300 million years ago. The land was invaded several hundred million years ago, and these fish developed the ability to crawl out of the water and start to use air rather than gills, so they had lungs. And from those quadrupeds, four-legged species, other species evolved. Dinosaurs came to dominate, and probably a couple of 100 million years ago, mammals evolved. And from those mammals, we evolved. But many of those stages involved transitional animals. There weren't very many of them, just small numbers. We have found some of them, but they're very, very precious. They're very hard to capture because you're talking about things that perhaps weren't around for very long before something else dominated. And so trying to spot these gaps and fill them in is always going to be very, very difficult. But just because we haven't seen the things that fill in all of the gaps We can see these things either side of those gaps, and that tells us a very compelling story about how we evolved.
All right, Chris, a couple of questions via SMS. One saying, why does a can of beer or cold drink left in the deep freeze expand when removed?
Right, what happens when you put water into the deep freeze is that water is a very unusual molecule. The vast majority of chemicals and elements and compounds that we know about, when you cool them down and they turn from a liquid into a solid, which is what happens when water freezes from a liquid into ice, they contract and take up less space. Water, when it turns from a liquid into its solid, the water molecules arrange themselves in a slightly different way in 3 dimensions, because the most energetically favorable arrangement is with them organizing themselves the way they do to make ice. But that actually takes up a lot more space for each water molecule than the liquid does. So therefore ice expands and gets bigger. And because ice gets bigger and expands, that's what makes it float, because it's less dense. And if ice didn't do that, then we probably would have no life on Earth. It's this very unusual property of water and water's chemistry. When you put your can of beer or a bottle of wine or a bottle of drink into the freezer, the water freezes, turns into ice, and ice takes up a lot more space, and that's why the bottle expands and in some cases actually breaks apart, or your can of beer pops.
All right. Our last question that we'll have call-wise, Zandi in Pretoria, your question for Dr. Chris.
Hi, Koketso and Chris. I'm diabetic and I normally run road races. So I wanted to ask Chris, I've noticed that when I finish a 10K or a 21K, my hands are always heavily swollen. If there could be a reason for this.
All right, got you there.
Diabetes.
Can you just summarize the question for me? Because I couldn't hear it very well.
She is diabetic, and she finds that once she concludes her, she's also a marathon runner. When she finishes a 10-kilometer or 20-kilometer race, she finds that her hands are heavily swollen. Is there a reason for that, or does it have anything to do with her diabetes?
It's unlikely to have anything to do with your diabetes, and congratulations on your marathon prowess, by the way. Taking regular exercise is an excellent thing for anyone to do, and diabetic people, no reason why they can't benefit from the health benefits of taking exercise either. So Steve Redgrave, who is a very, very good rower, won some gold medals at the Olympics for Britain, and he's diabetic as well. Now, there's not really any reason why your diabetes should cause your hands to swell. I think what's more likely is that when one takes regular exercise in the heat, what you do is become very good at maintaining your body temperature by doing what we were describing at the beginning of the program, opening up blood vessels to supply the skin with intense or enriched blood flow to radiate heat away from the body to keep your body temperature correct. When you increase the blood flow through the skin, you increase the volume of the skin, so everything that's getting an augmented blood flow, because blood takes up space, will get a bit bigger. And also, when blood flows through the superficial tissues, it filters liquid into the tissue. Some of the liquid comes out of the blood vessel and sits around the blood vessel a little bit more because the blood flow is higher, and that contributes to the slight swelling as well. So I suspect this is a consequence of you getting hot when you're running and diverting more blood flow down into your hands.
All right. Dr. Chris, that is all we have time for. Thank you very much, as usual. Thanks for your calls and SMSs as well. It is the Ridi Tlhabi Show. Koketso Sachane in for Ridi Tlhabi.